Segment of a circle. The segment of a circle is the region between a chord and an arc subtended by the chord. So this line here is called a chord. So the segment is the region between this chord and this arc that's subtended by the chord. So here's the arc of the circle and a chord that makes up this segment here. Note that C represents the length of this chord and R is the radius of the circle. We have formulas here for calculating what this area of the segment would be. We use a different formula based on whether the angle is given in degrees or radians. Really, if we took this whole segment and the area of the triangle, we would have a sector because this is a central angle with vertex at the center. So if we took the segment and this triangle, it would be a sector. So the area is the area of the sector minus the area of this triangle. That gives us the area of this segment. So this same thing here is the area of a sector if the angle was in radians. So this whole sector, subtracting the area of this triangle, this represents the area of the triangle, that gives us the area of the segment. Okay, let's see an example. Example 4. Find the area of the segment of the circle when theta equals pi over 2, the radius is 3 inches, and C, the length of the chord, is 4 inches. Since they give us theta in radians, we'll use the formula for calculating the area of the segment given radians. So here's that formula. It's the area of the whole sector in radians minus the area of the triangle. We'll substitute the given information in the formula and simplify. So the radius was 3, the angle is pi over 2, and C, which is the length of the chord, was 4. So we put 4 where there's C's here and 3 where there's R because that's the radius. And then we just have to simplify this. 3 squared, which is 9 times 4, would be 36. 4 squared would be 16. These 4's cancel out. Then we have 3 squared, which is 9. 2 times 2 is 4, so we get 9 over 4 pi. 36 minus 16, take the square root of that and subtract it from this. Looks like we could just put all this in the calculator and approximately get 2.6 inches squared for the area of the segment.